Great. So welcome to the Python review session. As I said before, my name is Sonia, and I'm super excited to be teaching this class, this Python review session and CS109 in general. So just a little bit about my background. This past summer, I co-lectured 106 AP, which is 106A, our intro class, in Python. And 106A is now completely ported over to Python, which I think is indicative of the trend of the way that the world is going. So Python is a fantastic language, and I'm really excited that you all are here and trying to learn Python. Because when I took 109, does anyone want to guess what language I did all the assignments in?
Java.
I did one in Java.
C++.
Nah. I did it all in Excel. But I think that I could have saved myself quite a bit of a headache if I had actually learned Python. So I'm really glad that you guys are all here and learning Python. So just to give you a little bit of an overview of what we're going to do today is that first we're going to talk a little bit about how Python compares to other programming languages. Then we're going to dive into just the basics of Python, and then finally we'll do just a little bit of demoing at the very end just to see Python in action. And I guess the one caveat to this whole session is that it would take much more than an hour for me to teach you all of Python and all of the related packages that will be useful for you in this class with Python. But the goal of this session is to just get our feet wet in Python and just give you sort of a background for, this is how Python works, and then point you towards some resources so that you can study it on your own. So, just went over the overview. So how does Python compare to other programming languages? So if you took 106A in Java here, this should look kind of familiar. We're just trying to create an array list here where we're including just the even numbers, and then at the very end we're printing all of them out. Kind of similarly, if you took 106B here, this should also look fairly familiar, and it looks kind of like Java. And then some of you might have a little bit of experience with JavaScript. We see that instead of declaring like array list evens, instead we're just declaring it as just a variable. So we're getting a little bit towards Python, but in Python, ta-da, this is Python. And you'll note that it's a very syntax-light language. There are no semicolons, there are no curly braces, but the things that do all the magic are these colons and then the white space. So in general, when you see Python and it's indented, it's being indented with 4 spaces. And so this is all that it takes in order to construct a list of even numbers and then print it out. So there's one even more condensed way of doing this. It's using a list comprehension, which is something we're not going to be covering today, but it's a completely elegant and Pythonic way of dealing with creating lists and manipulating lists. So that's one other cool thing. So we're going to go through a number of different Python basics, and I've adapted this from Sam Redmond's CS109 class. That's not being taught this year, but I've linked to it at the very end of these slides because it's a fantastic resource if you want to learn more about Python. So if you have Python 3 installed on your computer, and I'm just going to demo it right here, what I can do is just type in Python 3. Oh, I'm already there. Uh-oh. So if I just type on Python 3, what I get right here is called the Python interpreter. And it's an interactive interpreter that allows me to write code and then evaluate expressions and whatnot. And it's a really powerful tool for testing things out, and then also for reminding yourself just how does Python work. So now I'm just going to skim through a bunch of things about Python. And since all of you have somewhat of a coding background in another language, hopefully I'll be relating back to the other languages and you'll be able to see how it works in Python. So for comments, we just use the £sign. But if you want to write a multi-line comment, generally you'll write it inside of 3, what is these? It's double apostrophe marks. Can't remember what, quotation marks. There we go. So it'll look something like this. Now, if you've coded in Java or C++ previously, you'll be familiar with this int x equals 0, semicolon syntax. So it's got the semicolons, it's statically typed, which means that whatever you put into the x variable has to be an int. But with Python, there are no semicolons and there's no type declaration. So in Python, variables are dynamically typed. So even though you can't see the type there, Python knows what type is associated with x. So for example, just going back to here, so I said x equals 3. If I type in type x, it'll tell me that x is an int. So Python knows even though we may not be saying it explicitly. So just to give you an overview, Python has two different numeric types. We've got ints and we've got floats. So if you want to declare an int, you don't use decimal points, and if you want to declare a float, you should use decimal points. Basically, if you're doing operations like division, it's going to default to the value going to be a float, unless you explicitly do integer division, which you have to do using two slashes. So that's the operator for integer division in Python 3. So everything I'm going to be teaching today is all Python 3. And then, just like other ones, other languages, you've got modulus right here. And then also right here is exponentiation. So if I wanted to say 5 to the power of 2, I'll just say 5 star star 2. If I wanted to be 5 to the power of 3, 5 star star 3, and so on and so forth. And if people have questions at any point, just feel free to raise your hand, or don't even raise your hand, just like shout out if anything is unclear. So to give you an overview of what Boolean operators look like, you might be familiar with like pipes and ands. Well, the really beautiful thing about Python is that it mimics our natural language fairly well. So you'll find that often Python code is fairly similar to pseudocode. So instead of using the this exclamation point, we just say not. Instead of the pipes, we say or, we just say and, etc. One thing I just want to give you a little caveat about is that this keyword is only used in particular situations where you're wanting to make sure that whatever you're referring to is the same exact Python object. That is to say that it's at the same address in memory. So be careful with is, and in general, you're probably going to be using equals equals. So just an overview of what that looks like in practice. If I say 2 times 3 equals 6, that evaluates to true. If we say not true, that's false. And then true and false is going to evaluate to false. And there's Boolean short-circuiting inside of Python. So in this case of true or false, it basically says, okay, if I'm looking at this or right here, and the thing that's before it is true, then I'm not even going to look at what's here. I'm just going to automatically evaluate it to true. Similarly, if this said like false and true, this wouldn't even look at what's on the right side of the Boolean expression. It would just automatically evaluate it to be false. And you can use that to your advantage. In some cases, it means that you have to do less error checking. And then you can also chain operators. So in this case, we're evaluating that 1 is less than 2 and 2 is less than 3. So there's no character type in Python, so everything is a string. And you're allowed to use both single quotes and double quotes. Both of these are creating string literals, but the biggest trick is that you're just being consistent about them. Although we're not going to be grading you on your style, you just want to make your life a little bit easier. And then this is just a little example of what string concatenation looks like. So you're allowed to mix them. It's all still going to be a string literal. So now what I'm going to go into is indexing. So this should look fairly familiar, and I just took the slides straight out of CS109 since I think this and the next slides are fantastic slides and I didn't want to recreate them. Kind of similarly to like if you were working in C++, if you index into the string at index 0, that'll be A. If you index in at index 4, that'll be U. Because right now we're just looking at whatever is to the right of that particular index. And then if you try to index off the end of the string, that's bad and that results in an error. One other thing that's really cool inside of Python is that we have negative indexing. So if you want to just get the last thing that's inside of a string or another container type, you say, the name of the variable and then your brackets and then just -1. And that will give you the very last character that's inside of that string. And then similarly, that applies that way as well. Now, one thing I'm going to spend a little bit more time talking about is slicing. And this is something you might not have encountered in some of the other languages that you've programmed in. So just want to spend a little bit more time looking at it. So for example, say I've got this string called Arthur, and what I want to do is get a substring that just contains A and R inside of it. The way that I'm going to do that is, again, using very similar notation to our indexing. I'm going to say, the string's name, bracket, and then what I'm going to put right here is the index that I want to start at and the index that I want to end at. And note that this is not inclusive. This is exclusive because we're getting 0 and 1, but we're excluding 2. And that will give us AR. Now, if I want to get HUR, then similarly, we know that we're starting at index 3 and going, the very last one is index 6, and it's not inclusive, so I'll just say S from 3 to 6 equals HUR. And then lastly, if I want to do R through H, I can just do 1 to 4. Any questions on this? Yeah?
Can you go backwards, if you want to go RUH, can you go from -1 to -4?
So if you want to go RUH, the way that I would do that is by using a second colon and then an optional argument. And actually, I'm going to demo it in just a second. So you'll see it, and then if it doesn't make sense, just raise your hand again, and we'll demo it in the interpreter. So just one thing about this is that you saw previously we were saying 0:2. We don't actually need to do that. We can just say :2, and it will implicitly fill in the start index as 0. Likewise, if you just want to go to the end, it'll implicitly fill in the end index as the length of the string. Okay, so going back to your question. So one thing we can also do is pass in a step size. So this is going to tell us, I'm going to start at 1 and end at 5, but I want to just step by every other. So once I've gotten this one, I want to go 2 indices over. So start at 1, go over 2. That'll give us H. And then go over 2 again. Oh, we're past 5. We got to stop. Similarly, and this again goes kind of towards your question, we could start at 4, which is U, and then we can step, and then it says go, quote, quote, to the end. That's not necessarily this end. It's going to be going this other end. So what we are going to do is step by -2. So we're going to say, first we're going to get whatever's at index 4, then we're going to go -2, then get whatever's at index 2, and then get whatever's at index 0. So again, this is kind of some fancy stuff that you won't necessarily use every day, but the reason that I include this is because something that's going to be probably useful to you is this notation. So if you say : -1, that says start at start index, end at end index, and just reverse it, step backwards through the string. And so this is a pretty common paradigm for reversing a string, and we also use it for reversing other container types. Did I answer your question?
Yes.
Okay, awesome. So speaking of container types, there's this awesome thing called a list, and it's super versatile. It's kind of like an array list or a vector, but you can do all sorts of things with it. So these are a number of different lists. You can see the first one, it's got a bunch of numbers in it. Always lists are going to have the open and the close brackets, and the different elements inside of it are going to be separated by commas. And then this is a list that has just one element inside of it, and that element is a Boolean value. You can actually mix up the types of whatever's inside of here, and you can actually put lists in lists, which is a very handy way of representing a 2D array. And you'll actually find that one pretty common pattern for working in NumPy, which is one of the packages you'll probably use a lot, is like first you read in a list, well, depending on, but how you do it. But sometimes you'll just like read in a list of lists, and then you'll convert it to a NumPy array, and then you'll just have a 2D array. So that's a pattern. And then if you want to have an empty list, it's just bracket, bracket. So the big trick about lists is that it's a linear collection, and duplicates are totally allowed. So if you want to just see what's inside of it, you can index in just like you would index in with a string. And then you can also slice it, just like you would slice with a string. Now, one thing that's super handy is the length built in. You can basically call length on, like you can call on strings, you can call it on tuples, you can call it on all sorts of different types. It'll just give you the length of the container type. Now, if you want to add elements to a list, if you want to add a single element, what you're going to want to do is use .append, and then you just stick the single element inside of here. And that will modify the list in place. Similarly, you can use the plus equals notation, and that will also modify the list in place, which kind of makes it a little bit special in Python. This is a fast operation, and it's actually faster than saying list equals list plus 7, 8. But that's kind of fancy. So yeah, if you want to add multiple things, you can use plus equals or the method extend. Although I prefer plus equals because people always confuse extend and append, and plus equals is just easier to remember in my mind. But the trick with this is that you have to be adding on a list. You can't just add a single element. If you want to remove elements, there are a number of different ways to do it. You can Google many of them. And in fact, one of the things you're going to learn about learning Python/using Python is that Google is your best friend. So never be afraid to Google things, and sometimes it will save you time because you're trying to implement something that people have already written like a string method for. So if you just want to get rid of the last element here, you can pop it off. That will modify the list. It'll just say 1, 2, 3, 4. And then it will return whatever value you popped off. You can also pass an index in to it just to get rid of one of them. And another thing you can do with lists is query for membership. So for example, in this case, I can just use a string literal, or I could also alternatively use a variable. And in this case, I'm saying, is the string literal mango inside of fruits? If it is, then I'll get true back. Is broccoli in fruits? False. And then I can also use not with this keyword in. So if I say broccoli not in fruits, that's going to be true. Any questions on membership queries? Yeah?
I have a question about the lists in Python.
Yeah.
I forgot which one it was, but I was wondering in Python if you remove an element from the middle, does it shift everything else to the left as well? Or
If you remove an element, so okay, let's check. So right now I'm going to demo. If I ever have questions about Python, my first thing that I always do is I go to the interpreter. So for example, I'm just going to say LST, that's kind of our idiomatic name for a list, is A, B, C, D. Okay, now I'm going to say list.pop, and I'm going to pop B off. Now, list says A, C, D. So the thing with lists is that they're never going to have like empty space inside of them. It's like the length of the list is always going to be the number of elements inside of the list. Okay, looping over a list. So we have a number of different ways that we can loop over a list. Here's our happy fruit list. So this is the syntax for each loop. It should look fairly familiar, but you don't have to use any parentheses or anything. You just say for fruit and fruits. And so for this one, for fruit, that's going to be the variable name for whatever it is inside of your container that you're iterating over. Yeah,
well, I
question?
can name it whatever I want, right? Like
Yeah, I
can
could say
cats and fruits.
For what?
If I can I do for cat and fruits?
Yeah, for cat and fruits, totally allowed. It would do the exact same thing as long as you said print cat. Maybe or maybe not advisable, but I know, yeah, totally. Yeah, but one thing you'll often see as just a pattern is like for singular in plural. So you'll see that often. So for each loops, super nice. They don't just apply to lists, and we'll see that in a little bit later. One other way you can do this is using a for range loop, and this is analogous to our classic for loop that we're familiar with from many of our other languages. So what's going on inside of range? Well, what it's doing is that it's implicitly saying, I'm going to start our counter at 0. And then right now what we're passing in is the end index for that counter. So we're saying once that counter reaches the length of fruits, then we want to stop. Which is very similar to this. But also this for loop is going to implicitly be incrementing, well, it's actually range that will be incrementing I. So that's kind of the anatomy of what a range loop looks like.
Does it initialize I to 0 automatically?
If you just pass in one argument, then it will initialize I to 0. Again, it doesn't have to say I. You can call it whatever you want, but I is sort of the classic thing that you would call it. But in just a second, I'm going to show you if you don't want to start at 0, this is how you do it. Any other questions on this before I show the other range things? Okay, now I'm going to show you range. So range is a built-in in Python. There are a number of different built-in functions inside of Python. So the general anatomy of range is that we've got the start index, which is optional. We've got the end index, which you have to provide no matter what. And then we've got the step, which is likewise optional. So in this case, if you say range 3, it'll just go from the start index to the end index, not inclusive. If you want to start from 5 and say like range 5 to 10, it'll start from 5 and then go up until you reach 10, but not including 10. Now, similarly to the slicing deal, you can start from 2, go to 12, and then just skip by 3s. And that's the step size. And then also kind of like the slicing thing we saw is that you can pass in a step of -1, and that means that you'll be counting down. Cool. Any questions about that? Did that answer your question? Yeah?
Just a question. Can you, like, can range, like, go out of bounds, for example, if you don't specify it at any point?
Can
Or
range
is it
go
supposed
out
to
of
be-
bounds? Yeah, well, the thing that's kind of funny about, what do you mean by not specifying an ending point?
Like, if you just have, like, range, for example, range -7, comma, comma, -1, is that allowed?
Let's check it out. It doesn't even let me type the rest of it. It'll say invalid syntax. But sometimes one thing that you'll encounter is that, especially if you're using a negative step size, is that you'll have flipped around the start index and end index. So it will never be executing your for loop because it's like, oh, you've already gone past the end index, so I'm going to stop. If that block of code in there isn't executing, then you'll want to flip around the two. That's just a common bug that I've seen. And then one final way of looping over things, I didn't know about enumerate until like way too late. It was probably 2 years after I started using Python. No, it was a year and a half. Anyways, so enumerate will loop over a list, but it will not only loop over a list, it'll also have a counter going. So what's going on here? We're printing both the index of the element and also the contents of that particular element. Any questions about enumerate? Yeah?
Isn't also that I can do that with the in range as well?
Yeah, you can use that using for I in range, but enumerate is a super elegant way of doing it and slightly more Pythonic. Yeah?
How do you can you access things within enumerate first? Like it looks like it's like it comes like the things in it are in pairs of like number and
Yeah. So basically, the very first time that we go through this for loop, I will equal 0 and fruit will equal 1. Or sorry, not fruit will equal 1. Fruit will equal banana. Apple. There we go. Thank you. And so for this entire code block, it's going to equal that. But then the next time you do it, it's just going to be the other two, and you can't mix and match. Sorry, was that your question or?
so I guess within the code block you could do like enumerate fruits and then like bracket 1 and then that would be like apple or something?
Oh, if I were to inside of here also do another enumerate?
Or like can you access the things in enumerate? Or is it like a vector or anything? Or is it just like
What is enumerate? So enumerate is a generator, and it generates tuples. Generators are not something that I'm going to cover in this session, but basically it's just going to be like handing you pairs of values one at a time. I'm not sure if I'm answering the question.
I was just like so say you have a for loop and then like I don't know, maybe it's like you're going through and you want to find like which one's banana or something and like you want to like print out at the end that it was like the second or something. Is there a way to do it with enumerate or do you have to like make your own variable and then print that variable out like later? Does that make sense?
Yeah, so a couple of different ways you could do that. One is just like to store the index, just store whatever I you find banana at. And then the more like the Pythonic way of doing it is using, I think find might just be a string method, but I'm pretty sure that there is just like a method that you can use on lists. I would have to Google it to just find the index of a particular element. So that's kind of like the fast way to do it. But if you want to talk more about this after, I'm super happy to do that. Yeah?
Okay, I'm just not getting what enumerate adds. Like I don't see any new functionality introduced. You still printed the index and then the fruit, right?
Yeah, so enumerate is not doing anything that a range for loop can't do. It's just considered to be a slightly better style. That's all. So to go over what control flow looks like, you might be used to having parentheses around the condition that you're evaluating and curly braces, but instead we're just going to get rid of the parentheses, stick a colon, and indentation instead of having our curly braces. So this is what your classic if statement is going to look like. And then this is an example of what an if, else block looks like. Instead of writing else if, we write elif. And you don't have to have elif, just with, or even else, with, just as in other languages. But one thing just to note is that there is no switch statement in Python. So the classic way to do things is just chaining if, elifs. Now, this is what the anatomy of a function looks like inside of Python. So we've got the def keyword, which is saying that I'm about to define a function. Then you put in the function name and then the parameters. One note about this is that the parameters are not explicitly typed. And hypothetically, you could write a function that works if you pass in things of different types. Okay, that's not advisable. But the gist of it is that you're not typing your parameters here. And then again, you're still using the same colon and then indentation thing here. One other thing to note is that functions can return multiple values. And I'm going to demo a little bit more about tuples later, but basically what's happening is that when I say return result 1 and return result 2, we're returning a tuple, which it contains like result 1 and result 2, and then we can unpack it into two different variables later and then just use them separately. But this is one really awesome feature of Python. Okay, so now I'm going to start switching over to the demo. There are a couple things that we're going to cover. Some of it is just a little bit of an overview of getting set up with Python, and then using Jupyter Notebooks. And then the other things that I think are important to talk about are dictionaries, which are analogous to maps and there's kind of like like hash maps. And then also objects in JavaScript. There you go. That's what I was looking for. We also have sets and tuples that we'll talk a little bit more about. And then I'll demo a little bit of the use of other libraries and file reading. But again, I'm just going to be kind of glossing over things and getting you familiar with the Jupyter Notebook. Any questions about the stuff that I just blazed through? Okay, awesome. Let's switch over. Okay, so and at the very end of the slide deck, which isn't posted yet, but I am intending to post it, I'm also just including a number of different resources. So feel free to go there if you want to learn more about Python, because it will become very, very handy in the rest of your life. Okay, so now we're going to go to the demo. And I actually have it already open right here. So just to give you a little bit of an overview of how this works, if you click on that link, which is also posted on Piazza and the course website, sometimes I was having some problems with GitHub. So normally if you click on this, this should just render. And it's working now. It wasn't working last night. So I just included an alternative thing in case people are having that GitHub bug. So you can look at it here and just read through the whole thing. And I think it's decent reading. But if you want to play around with a Jupyter Notebook, which is an interactive way of viewing and writing Python code, and it's also very modular, the way that you're going to do that is by downloading this IPython notebook file. You can just download this entire thing. And then what you're going to do is go to the particular place where you've got it saved, and then all you do is type in Jupyter Notebook. And this is assuming that you've installed Jupyter, which you'll have to do via pip. So I know that a lot of you are going to be in different situations in terms of whether or not you've got Python installed, pip installed, and or Jupyter installed. But right now I just want to demo what it looks like. So there we go. And this will open up. And I guess just for a show of hands, who has Python installed on their machine? Okay, cool. Yeah, most people with Macs will have it installed. And I guess the one thing that I do want to put in as a caveat is that previous versions of this course have used Python 2.7, but this quarter, all the resources that we'll be providing to you are in Python 3. If you like Python 2.7, totally cool. Go for it, use it. But Python 3 is kind of the way of the future and what we're going to be doing and supporting in this class. Okay, so if you don't have Python yet, just download the Anaconda distribution. But if you do and you don't have pip yet, make sure that you are getting pip, which is a package installer. And in order to do some of the stuff that comes later here, you're going to need to install the packages NumPy, SciPy, and Matplotlib.
If we have Anaconda, does it automatically come with?
Yeah. If you've got Anaconda, these ones will come bundled with them. Actually, I'm not sure about Matplotlib. Probably. But yeah, if you don't have Anaconda, then you'll have to do this manually. Yep.
Is the pip3 install, that's run directly from the command line in Bash, not in a Python?
Yeah, just directly on the command line, exactly. Cool, so if you want to run a Python script, the classic way of doing it is you write your Python script. What I suggested on the Piazza post was downloading a text editor like Sublime. I'm a total Sublime junkie. Writing that script there, and then just saving it with the extension .py. And then you just say Python 3 and then your script name, and then you can just run it directly from the command line. Also, you can create your own Jupyter Notebook. which is the thing that I'm in right now. And there are a lot of pluses to that in its own way. The really cool thing about Jupyter Notebooks is that I can just like add cells and like write code right here and just execute it. And the way that I execute it is by printing shift return. And this number to the side right here is telling me in what order I've run the cells. So like if I say now y equals 2, I just ran that, so this is like the 4th cell that I've run, and I run this again. Oh, now it's 5, etc. So this is just an overview of what like Jupyter Notebooks look like. And you don't like you should be careful about what order you're running the cells inside of a Jupyter Notebook, because it will be going in order of like how recently you've run the cells. So sometimes you'll like change code somewhere, and you'll need to run that cell again in order for like a different cell to work properly. Any questions about Jupyter Notebook? It's kind of a little bit of a quirky tool, but also very useful and in fact, wonderful for data analysis if you want to be able to visualize data, because it integrates super well with matplotlib, which is our plotting library. Okay, so we've gone through the basics of Python. This is something you can go through on your own just to review later. But what I want to go down to is string formatting. So previously I showed string concatenation inside of here. You can also do C-style string formatting, but my favorite way of doing it is using F strings. So in Python 3, so let's see, say my name is Sonia, and my age is 23. So if I want to say, like, if I want to print a string that's saying, like, hello, Sonia, you are, and then my age, one way I can do that is using an F string. And I just say F, and then hello, and then I can just say the name of the variable that contains whatever I want to be using. Hello name, you are, and then age. So if I run that, it'll say, hello Sonia, you are 23. Anyways, that's just for fun. F strings are super awesome and really nice if you're like doing print debugging for formatting things. Here's a whole coterie of different string methods that could come in handy, and this kind of ties back into the idea of like if you want to do it and it might be easier to, well, basically if you want to write something like a little function to do capitalization, just give it a quick Google search to see if it's already been written. Because, yeah, it's really, there's lots of great stuff that's already built into Python. Okay, containers. So we've talked about lists. We've brushed on tuples, and I'm going to gloss over sets and spend a little bit of extra time on dictionaries. So the general idea of a dictionary is that it's like a map or an object in JavaScript. So the way that dictionaries work is that you've got key-value pairs. So if I want to say, like, okay, dictionary equals, yeah, well, let's see. Say I've got a bunch of pets. In fact, I've got chickens, as I mentioned before. And I'm going to list off, like, the chicken name and then, like, the number of times a day that they need to be fed. In reality, chickens know how much they need to eat, so they just take care of themselves. But this is just an example of how you can use this. So here's another. So what I'm doing right now, and I'm actually just going to comment this out because I think it's more fun when it's happening in real life. Amber's super hungry. So when I execute the cell, I'll create a dictionary. And so when you're creating a dictionary, the outside are going to be the curly brackets, and then you're going to show the key value mappings just using colons. If I want to see like how many times Kala needs to be fed, I'm just going to, well, in fact, it will evaluate whatever the last thing in the cell is, so it'll just evaluate 2. So another fun thing about Jupyter Notebooks. So I can I can basically go to that particular key and then get the value associated with it. And then if I decide, oh, you know, Kala, she's been pretty active lately, so she needs to be fed more frequently, I can reassign the value that's associated with Kala, and then I'm just going to print out the dictionary again. And now you'll see that Kala equals 3. So dictionaries are mutable. You're allowed to change them. And one other thing is that I can add new keys. Like, say I get a new chicken that I'm going to add to the flock, and her name is Rhea. So if I want to just add her to the flock and say, she doesn't need to eat that much, I'll just say that she needs to eat 2 times a day, and I print out the dictionary. You'll see that Rhea has been added in here. And then finally, you can also do membership queries with the dictionary. I'm just going to do this in a new cell. Right now, we know what D is. I don't need to all do that just in the same cell. I'm doing this in a different cell at this point. So I've got D, and if I want to just see if like Rhea is in D, this will return either true or false. Again, the same sort of membership thing that we saw in the lists. And then I can also say like, let's see, Lyle. I had a chicken named Lilac who turned out to be a rooster, so we had to give him away. And we found that Lyle is not in the dictionary. Sorry, Lyle's not in the dictionary because Kirkland ordinances don't allow us to keep roosters, unfortunately. So again, you can do membership queries, and you can also dynamically add key value pairs to your dictionaries. So dictionaries are just super useful. One other thing that's kind of nice is that if you want to do the same sort of thing when you're accessing the value that's associated with a key, this syntax will do the same thing, although it has one added benefit. If monkey is not inside of this dictionary, it will return NA. But if monkey is inside of the dictionary, it'll return whatever the value is associated with monkey. Okay, cool. And then if you want to just iterate over the keys inside of a dictionary, you just say for and then whatever you want to name the key in the dictionary name. You can just do whatever you want with that. But if you want to access the keys and the values at the same time, then you can just say like for whatever you want to name the key and then whatever you name the value in dictionary.items. That will be iterating over the key value pairs. Again, you can do that just using the classic for each loop over the keys, but this is considered to be like slightly better style. These are dictionary comprehensions, and you don't really need them for this class. These are sets. Sets have curly braces, and they behave like sets in other languages. There are methods that allow you to do union, intersection, adding, removing, etc. on them. And yeah, sets are nice, but we don't need to go into them too much because they're pretty self-explanatory. Lastly, there are tuples. So when here, and I'm going to write a quick little program, and what this program is going to do is return a string with all the e's removed, and then also the number of e's that were inside of that string. So I'm just going to say count equals s.count and then e, and then I'll say with the e's removed, I'm going to say s.replace, and then I'm going to say replace all the e's with empty strings, which means that we're just going to be getting rid of the e's. And then what I'm going to do right here is return removed, and then I'm also going to return count. So the way that this looks is that if I say the sentence is wheat bread, then when I get the values back, I'll just say like e's removed, comma num e's equals no e on s, and then I'm just going to print this out. So what you're seeing right now is that I'm returning 2 values, and then I'm basically unpacking it into these 2 different things. So if I print them, it'll just look like what Brad, and there were 4 e's inside of here. If I were to try to modify a tuple, like say this tuple has 1 and 2 inside of it. That's not what I meant to do. Well, that's okay. If I were to say, I want to say 1, 3, and I just try to reassign whatever's inside of there, I'm going to get a type error because you're not allowed to change tuples. They don't support item assignment. But the nice thing about tuples being immutable is that it means that you can use them as keys in dictionaries. Whereas with lists, you can't use as keys in dictionaries because they're mutable. So dictionaries can only have immutable types like strings, ints, and whatnot as their keys. Values can be whatever. But sometimes people represent grids using tuple pairs, particularly like sparse grid type things. Now, you can write classes. The syntax is pretty light. It's kind of nice, but we won't be talking about that very much. And I'm just going to give you a quick gloss over the different libraries that are going to be handy for you. So math allows you to do square root, exponential, factorial, and all sorts of other stuff. Random, super handy for this class. We both have the random module that we use for Python, but also there's np.random, which is NumPy's random library, which you also may want to use. So if I want to get a random integer between these two numbers, I can do that. If I want to get a random float, if I want to pick a random element inside of a list, I can just do random.choice. So that's very handy. I recommend looking through this, and you can also see the different distributions. This week we've been talking about like binomials and all sorts of things like that, and so SciPy is another package that allows you to do those really easily. You can do 10, choose 5 in an instant. So the general syntax for importing things is like, if you want to just import a particular part of that package, you can say like from SciPy import special. NumPy, we typically abbreviate to NP, so we'll just say like NumPy, but we're just going to call it NP wherever we write it. So array is the typical thing that you're using inside of NumPy, and a way that you can populate an array, there are many ways to do it, but you can just say np.array and then pass in a list. And that will automatically convert that list into an array. And as I mentioned before, you could also pass in a list of lists into that array, and that will create a 2D array. So you can evaluate the shape of it, and you can just see what's inside of it. You can also index into it to see like, okay, what's at the 0th row, 0th column, and so on and so forth. So I recommend reading through this just to check out and see all the different things you can do with it. And the very last thing that I want to mention, because I don't think that plotting is the most important thing, I just want to give you an example of what reading data in sometimes looks like. So the way that we typically read data in is we use with open, and then we pass in the file name. And if you want to read, then sometimes you also pass in a second argument that just has R as a string, which says, I'm reading right now. Alternatively, you could pass in W to say, I'm writing right now. And then we just say, okay, this file object, we're going to refer to it as F. And if I want to read in all of the different lines inside of this file at once, I just say f.readlines, and this will give me a list of lists containing, and each list is going to be one of the lines in the file. So that's just an overview of how you can do file opening and file reading inside of Python. So I know that today was a total whirlwind, and I just gave you exposure to some ideas in Python, and then at the very end we saw a little bit of the libraries that will come in handy in your Python futures. But I hope that you'll feel a little bit more oriented with Python and equipped to work through / read through this on your own and develop more familiarity and proficiency with Python. So thanks so much for coming today, and if you have questions, I'm hanging out, so feel free to ask. Oh. Thank you.